Welcome everyone, welcome everyone. This is the session. It's Advanced Analytics at Scale. We are Erik and Erwin, and we're from Tableau's London office, and we'll introduce ourselves a little bit later on. But let's first tell you a little bit about what this session is today. Today's session is all about how you can bring the world of the data scientists together with the world of the business user to start bringing both of their expertises together to get more value from Tableau. And you do that by bringing together Tableau with an external services like R or Python. Now today's session is listed as an advanced session, but whether you're in the room as a business user, we would want you to look at today's session, really see the art of the possible and what you can do with Tableau when you extend its functionality by bringing in an advanced analytical language. And if you're a data scientist, we want you to look at how Tableau can really help you scale communication of your hard work and labor throughout your organizations. In general, we want all of you to walk away from this session feeling ready and just secure that you can start rolling this out in your own businesses. So we're going to be talking about today.
So during this session, we're going to be talking about how to essentially drive collaboration between two very different sets of users within, for instance, your business user community, as well as your data scientists. But before I start, let me just ask you all, how many of you are currently using an external service connection with, for instance, R or Python or MATLAB with any of your Tableau dashboards? See a few hands cropping up, not a lot, and I'd say that's broadly indicative of what we see working with different customers. There's a lot of curiosity and appetite for really taking your analytics that next level, but when it comes to crunch time and actually pushing forward, not as many people do it. We're going to be trying to explore today a way that you can essentially have a framework to relate to this implementation. Finding a different use case, finding those internal stakeholders that are then crucial to bring this forward. Once you've essentially found that success case in a team, a department, how do you then go about scaling that out? Both from the standpoint of your business processes, but also from the standpoint of making sure that you're technically ready for that scaling process. Because we anticipate that this might conjure up quite a number of questions, we're going to try to leave quite a significant period of time at the end for Q&A, so please leave your questions until then. And let's then look at how we're going to drive this forward.
Yeah, so please leave those questions. I mean, it shouldn't be repeated at this point, but these sessions are recorded, so you can always watch it back. You'll also get the slides, so please take all the notes you want, but also feel very free to just sit back and listen to the presentation. Before we get real started, let's just start introducing ourselves. My name is Erwin van Laar. I'm a product consultant then here at Tableau in London. My background is not in tech. It's actually in healthcare. I studied public health, mastered in innovation and management. I worked at an occupational health service for a few years where we implemented a bunch of new IT solutions. But it wasn't until we started bringing in Tableau that we really started to unlock our business. Got an opportunity to move to London to work for Tableau, did that about a year and a half, or just over now, and never really looked back. London is a great place, of course, to be. Look at me, I like my food, I also like my theater, so it's a good place to be.
My name is Erik Polano. I've had the privilege of working together with Erwin now for close to 2 years. Whilst we work within the same team, we have somewhat different backgrounds. I spent a number of years in grad school looking at then how you could use applied statistics to essentially drive the discussion surrounding causal mechanisms. How do you understand if different things are in fact related to each other in a way that is meaningful? So for instance, within behavioral and experimental economics, looked at gender bias, within referral-based hiring and other related topics. After spending a bit of time at a different software company, found myself back at Tableau with doing my real passion of really trying to have data at the center of these types of discussions. And whilst not in the office, I have a bit of a geeky pastime surrounding doing a lot of stuff with Linux. I might have built with a Raspberry Pi very recently a Google Voice Assistant complete with a USB headset and keyboard that looks suspiciously similar to those in our London office. I'll leave it to you to decide if that's a coincidence.
For those of you who are, of course, now worried about Eric's social life, we are a very welcoming office. We do our best to get him out of the house at times.
You can see who's the most excited to be leaving that office in that photo as well, beyond just the silhouettes, hopefully.
But back to today's topic, right? We're talking about these two groups, which are business users and data scientists. And looking at our backgrounds, we sort of represent those groups already. I mean, I've worked as a business user, as a user of Tableau for years, always been very, very dedicated to my output, to my business, knowing all around the context that makes my business fly.
Whilst I, on the other hand, during those years in grad school, out with different organizations using Tableau, try to approach questions often from the standpoint of what assumptions do we have to make about the models that we're using that allows us to, in fact, infer certain meaningful points surrounding this. So whilst I try to use those models in that way, I'm of course somewhat separated from the day-to-day happenings of how that data may be collected.
Now, before we get into the rest of the session, we're going to lay you out a framework, how you can start building this solution with Tableau. But let's make sure that everyone in the room here is on the same page, whether you're a data scientist or a business user. And let's talk real briefly, but just about the difference between correlation and causation, just because we're going to use that in the example that we're going to be taking you through today. So correlation and causation are not the same, right? High correlation doesn't tell me if object X actually inflicts or influences the pattern of object Y. Now, we're going to look at these as an example. Let's look at these two lines. They follow a pretty identical path, and they're actually correlated 99.26%. Now, unlike Eric, I've never had a score like that at school, but they are pretty enormously highly correlated. Now, just by show of hands, if someone comes up with a correlation this high, who would be comfortable making business decisions based off that high of a correlation? Just show of hands and keep them up so we can see, everyone in the live stream can see as well. Great. Now, keep them up, and keep them up if I reveal what this correlation is, still feel comfortable making a decision based off of this correlation.
Now, it is of course possible that for some reason, not consuming margarine leads to a happier marriage. Maybe you've eaten more butter and you're happier because you're enjoying life. But if you think about it for a while, the chances of this just being completely random or spurious are very high. And if you think about all the different time series out there, the chances of completely meaningless things having these high correlations are also pretty high. So when we're trying to establish then whether something is meaningful, we need to always have an understanding of how we can control for these types of factors and inform that with our common sense and the context of which that data is collected in.
And that brings us to our example we're going to be using today. So as a business user for this session, let's assume I'm a marketing manager. And I've just invested pretty heavily in a new campaign. Beautiful campaign based on user stories and customer stories, but quite heavily invested. So we want to know, of course, whether or not that actually generated more revenue, if we made more profit off of that, and more importantly, should we do that campaign again?
Now, in an ideal world, we would be able to run an experiment. We would have one group of people who saw that marketing campaign and another group that just didn't, and we'd look at the difference between those two, and then we'd be able to make a pretty well-informed decision. Alternatively, we would run our marketing campaign, get into a time machine, go back to the beginning of that quarter, and see what was the difference. Now, it could be the case that we're in the movie Back to the Future, in which case I really want to know where Marty McFly is. But I also know that there is a very high likelihood that most finance departments aren't very happy to finance these types of experiments, right? So that leaves us with the question, what can we do instead? Well, we can use, for instance, an R package, like Causal Impact, built by the Google Data Science team, that essentially tries to use some clever techniques related to Bayesian modeling that allows us to see, are we able to predict something like that profit for that marketing campaign with other data, and see then, because we know that marketing campaign has a particular date, we know that causality can't run backwards, therefore we can extrapolate forward a trend that allows us to, in fact, have a counterfactual view of what could have happened had we not made that change.
That's a lot of technical terms. Let's just look at what that end product could look like, right? Let's open up Tableau Server and look at what Erik, my data scientist, has built for me to answer that question. Let's just make it full screen so everyone can see. So we are just running this Tableau Server currently, and I have a calculation running here. So first of all, the first step is that I need to select the value that I want to calculate. In this case, profit selected. Perfect. I want to look at if my profit increased, right? Whether or not that campaign generated more profit. Now, the second step is quite crucial. It asks me that I should pick my variables, but they should be able to predict the value you want to calculate, but not be affected by that campaign. So currently, there's Google Trends data selected, which is fine. Google Trends data is done on a bigger sample size. That's actually quite stable, and we use that in a lot of our other dashboards. And the current second value that's selected is quantity of leads. Now, quantity of leads is something, of course, that is impacted by the campaign. Actually, it was the thing that we wanted to target, because more leads would hopefully lead to more revenue and therefore more profit. Now, from a business perspective, in this case, I would know that I can select discount in this case, because remember that the marketing campaign was run on user stories and not on a sale. We didn't decrease our prices. So I'll just select discount to get a better approximation of the model. Now, you'll see Tableau running, and on the back end, Tableau Server is now connecting to R, running this Bayesian model, training the model, and responding it back into the dashboard. Now, whilst it's doing that, it's going to tell me that the model is still to be trusted, as in the significance level is done, and I can see that over $400,000 can be attributed to us running the campaign, which gives me that answer. We might actually want to run that campaign again. Now, this is the end product, so let's move back what this presentation's about. How can we set that up?
Let us just recap quickly this problem that we saw illustrated. Here, as that data science user, I was able to run that battery of diagnostic tests that was behind that check mark. I, at the same time, can essentially build it out, present it to a business user. Now, when you think about it, many organizations would, of course, want their business users to be trained statisticians, to be able to answer these types of questions. But it's not necessarily viable to do so, right? So how do you then bridge that competency gap between these two and improve the collaboration between them?
Which is what this session is about, right? How do we bring data scientists and business users together, both have their expertise brought in to have more value out of our business? So how do we propose to solve that? The core of it is Tableau Server. Tableau Server is already deployed for our dashboards and our information sharing in our organization anyway. Both data scientists and your business users will already live there. Now, the only thing that you can add to that is an external services. Whether you like working with R, you have a preference for Python, or maybe you want to work with MATLAB. All of these are what we then call external service connections we can leverage in Tableau.
So, at that point, when we think about what this essentially means, we are then able to increase our development cycle by essentially being able to leverage our data science competency with the knowledge of the context in which that data was generated in, whilst at the same time, and I think this is really crucial, increasing the visibility of what your data science team is doing and allowing it to be scrutinized and essentially try to bring it into line with what certain business priorities may be. Now, I've worked with a whole number of different organizations that have fantastic data science teams, but I would say that it's not uncommon to find that you have an organization, they feel that they're getting mature enough to essentially bring in maybe external competencies to see what sort of results that they can drive. They have maybe 1 or 2 contractors sitting in a corner, writing things out, maybe in an R script or in Python. You then, after a while, try to pull them into a meeting to present what it is that they found now that they've gotten access to all this data. And during that meeting, they mumble a few things about what they found and that things could be significant, maybe not, I'm not sure. Everybody tries to nod as they go through this and then leave thinking that, okay, with then 6 months down the line, you don't necessarily extend those contractors' roles in the organization.
Which is an absolute shame, because that value can definitely be added, but it's all in the working together. Now, what is the end goal here? You can say, well, it's of course not that easy to start bringing statistics into the hands of regular business users. But we would argue that we've done the same with Tableau, but it used to be with database administrators and access to data, right? We wanted to move from that conventional system to a data-driven self-service organization. So we just want to say in this session, we want to make sure that there's no longer a report factory when it comes to advanced analytical dashboards, or at least results, but a more iterative process in which it's more self-sufficient, and the time that it opens up allows you to do more deeper modeling. And even though there were a few hands in the room here, of course, I think it's a slightly biased room, as it is, of course, a session about that particular topic. We see that a lot of companies want to do it, not a lot do it already. Of course, a few do, as you look at this skill at Hallmark, and that's exactly what this session's about, right? Tableau empowers the entire organization, and it puts that power of advanced analytics in the hands of those that might not be trained as a programmer or a scripter. So let's bridge that gap. And when we do so, let's first define what we're talking about. On the one hand, we have visual analytics, which is what Tableau has always done. It's presenting data in an iterative and visual way.
And then we have, of course, advanced analytics. So how do you, for instance, use predictive modeling related to forecasting or counterfactual forecasting, as we saw in our example, to give indications to business users? Have, for instance, the possibility to do smart analytics, give recommendations or prescriptions with regards to how decisions should be made. What we're really proposing is a way how to fuse these two. So you can use the lessons learned regarding visual analytics, giving visual cues that are understandable and intelligible to a business user community around these forms of statistical analysis.
So with every solution, and it's the same as Tableau, we can use those lessons learned. So we have to make sure that that solution adheres to these 4 key principles. It's always important to keep these in mind, whichever dashboard they're building, whether or not they include an advanced analytical language. First of all, your dashboards have to be easy to use. The moment they're not usable to an end user, they will not engage with it in the first place. Second of all, of course, they need to be fast. They have to be responsive in its information. Nobody's got time for just waiting hours on end, right? Second of all, they have to be powerful, and particularly powerful in the information that it portrays and the insight that it brings to the end user. And then last but not least, it has to, of course, be very visual.
And a key component in all of this is that this process needs to be iterative. As you have these questions arise surrounding these use cases, having continuous feedback and communication between these two different sets of users, I think is the key component to driving the success of such an implementation.
So how can we then build that success? Let's get all our building blocks together. And the good news is that probably already have all of them. Just have to see a way in how to connect them. We start with Tableau Desktop. We start prototyping a solution, connect to that make that initial connection. Then we need Tableau Server to start spreading the news and spreading those dashboards.
And as a final component, that external service environment. So if you're looking at having your data science team with R, you could use RServe, which is a package that you can use to communicate between the two environments, or TabPy, or MATLAB. So all different options available to you within the same implementation.
So how would the setup look like?
So let's just walk through this step by step. So let's say that you're then beginning with Tableau Desktop. And you then, in that initial process of connecting it to that external service environment, have then maybe part of your model being built externally from Tableau or in conjunction with it. And once you're then building that presentation layer within a dashboard within Tableau Desktop, you're then ready to share it through something like Tableau Server, of course. Once you then want to publish that from Tableau Desktop to Tableau Server, you need to connect Tableau Server as well to that external service. For here, you could have that running within the same instance, or you could have a dedicated instance within your cluster for that external service environment. And then that's it.
And from an end user perspective, I of course do not have access to R or Python. I'm not trained in that. But I do of course have a way of me finding those dashboards within Tableau Server. I just connect to Tableau Server where I find my dashboards anyway, in whichever manner I would, whether it's my laptop or my tablet or my phone. And it's actually Tableau Server that's seeking that connection. It can even mean that me as an end user I'm not even realizing that that particular dashboard is calling upon an external service.
So let's talk through the implementation itself.
And the first step is discovery. So whenever we're talking about building out these solutions, we have to find out about our problem. And it's always about assessing the business value, which is usually triggered by a question. And it's my question in the example that we're using today: should we run that marketing campaign again? Now, by doing so, I'm asking Erik to see if he can build that solution for me. And in that way, we're already sort of the champions in starting working together on this particular issue. Hopefully, that means that we're already starting to build the nucleus of what we then call our Center of Excellence, which we're not going to discuss in depth. There's a specific session on it, but it's going to be crucial in making sure that this process is iterative and remains to be fed throughout the organization. But the Center of Excellence is pivotal in providing support to the organization. It's basically a backbone where people can go to when they have questions. It promotes best practices and mostly in general promotes that culture of what we then would call advanced visual analytics.
Let's now talk through the actual prototyping step of building everything out here. Because then, as somebody who's been brought into this project by Erwin, I then begin by, of course, understanding what data I have available to me. So, as I then start creating my model, I then have the possibility to build that model either externally or within Tableau, but then crucially have that presentation done to my end users through Tableau Desktop. Now, when we are building these connections between these environments, there are certain nuances with regards to how these calculations should happen, with regards to especially that it's a table calculation and we need to know these calculation types. Let's switch into how we actually build this. Here you see that I have an R environment on my left-hand side and Tableau Desktop on my right-hand side. My first step is connecting Tableau Desktop to this R environment. And what I need to specify in this case is where this external service connection is going to be taking place. As I have the R environment running on my own machine, I am now just running this off of localhost here from my server location, and I'm saying what port it should be listening on. At this point, I can then test that connection, and I can now see that I'm successfully connected to the rserve service. The next step is to build the calculation itself. So let us go into Tableau Desktop and create that calculated field. Here, I'm now going to be pulling in one of these 4 calculation types. All these 4 calculation types really indicate are what type of outputs I anticipate to get from R. Do I anticipate it to be a Boolean, true, false, an integer, just any whole number, a string with regards to it just being a text value, or script real, that it can be any real number or a float. Here, because I want to build that counterfactual forecast that can be any number within the real domain, I'm going to use script real. Here, I'm then going to call my field prototype, and I'm going to use that script real calculation. Now, I write in that R code that I'm going to use, and let's talk through how we link this with Tableau. I just want to pause for 1 second and make sure that everybody's aware that we're not going to be able to cover all the nuances of how these two integrations work, but there's a fantastic session happening tomorrow with some teammates of ours, Konstantin and Leonard, Advanced Analytics with R and Python, that I really recommend you to go to if you're interested in seeing how all this is built. That having been said, let's go in and pull in our different values that we have here within this data frame. I see that I have my y value, or my outcome variable, mapped to arg1, and equivalently so for x1 and x2, to arg2 and arg3. All that this means is that I'm able to then put in 3 different variables here into Tableau. Now, my outcome variable was my profit, and my first control variable that I was building in that prototyping phase was then my Google Trends data. And finally, I'm going to be pulling in that quantity of leads field. Now I see that that calculation is valid, and that I have a calculation type as that table one. I now see that that's been added, and I can now pull in that prototype calculation, and I'll see how on the left-hand side that is then sending that calculation into my R environment while sending the result set into Tableau so that it can be visualized here on the same chart. And I've now been able to present my end user with that final result within my prototyping.
Which I was very happy with. I mean, it gave me the results I wanted, but it could be used by the entire organization. So let's now set up this connection to Tableau Server so we can publish this dashboard up and share it with the broader community. And it depends on how difficult it is, of course, to set up Tableau Server to, in this case, R.
Luckily, Erwin, it's very simple. All that we need to do in order to set up the connection to Tableau Server can be easily done during a maintenance window, for instance, where you speak with that prior to with your Tableau Server administrator. You just define what host or that IP address that you need to use. You define what port Tableau Server should be listening on. Commit those changes with tab admin config, and then you're ready to start your server. That's it.
It's good to note that the values that you're putting in here are exactly the same values that Eric was just showing in the Manage External Service Connection window in desktop. So if it is just the host, the server location, the port, and potentially a password or a username. But if you're able to connect Tableau Desktop to your external services, your server can do the exact same thing with the exact same settings. Now we started discovering that we had a question that needed to be asked, and we started building that foundation, or prototyping that solution. Let's start building the foundation. Now with any dashboard that you build using Tableau, the use of titles and subtitles is of course important. And we would argue that it becomes even more important when we're talking advanced analytics and we need to translate the concepts that Eric's been using to the broader organization. Of course, these are the principles of guided analytics, but they need to be well applied to a dashboard that calls something like this. And it's all about interactivity. For us to make sure that this is then carried out as a framework throughout the entire organization, we could start using parameters to switch out those values. We just saw in the prototype that Eric put in the values cleanly, but we can start using interactivity and parameters to start building a more iterative environment in which the model will continue to be valid, but the end user can start playing around with the values they're bringing in.
Let's therefore look at this in practice. How do we go about building this interactivity, including the mic falling on my feet here? So the first step that we want to, of course, look at is maybe we want to test the significance of this. Are we able to, for instance, evaluate the significance of this model? So I'm just pulling in here my p-value here from my summary object, and what I've built here are different parameters that link to those fields that I'm pulling in. So for instance, when I look at my variable, what am I trying to predict? I can see here that I have all of those different values that I can then have people switch out, and that will drive the switching of those measures. So I do that for my outcome variable. I do that as well, for instance, for my variable for what I'm going to be using as a control. And I now say I want to be able to compare that significance level, or that p-value. So I start thinking that I want to make that a parameter as well. So now I say that I want to calculate here my significance level. And what I'm going to say is I want to make this a list. That I then want to say I want to maybe have this tested on the 10% level, the 5% level, and for the 1% level. And I feel that now, as a data scientist, my role is done.
Absolutely. But as a business user, I have no idea what he's talking about when it's significance level, right? And Tableau is trying to help us every step along the way. I mean, we can call these parameters whatever we want. We can use significance level because, of course, it's a valid term to use, but we can call these things like how sure do you need to be, just to make sure that the end user knows what we're trying to do here. It's always good if you're on a different laptop than your own, right? There we go. I do want to point your attention to Tableau actively asking me how I want to alias and display the values that are very normal, of course, 10%, 5%, or 1% interval level, how we want to display those to the end users. Do we still want that to be 10, 5, and 1%? That doesn't ring a bell. Or are we going to alias this as somewhat, very, and extremely? And this way we're building a parameter that is much more understandable to the end user. So try and use those values that Tableau is already actively bringing to you, sort of like translating a dashboard using its own terminology, or creating a terminology that's more applicable to the business user.
And as a final step, what we're able to, of course, incorporate are those lessons that we learned when we were building out dashboards before. Instead of exposing that p-value then, and maybe that parameter with that helpful natural language question, we can, of course, try to guide our users using visual cues. What are, for instance, maybe something more as simple as a check mark to say that the majority of the diagnostic tests that we've determined to be important for this model should be incorporated. Different colors if we want to incorporate more nuance into this, and other shapes.
So this session is called Advanced Analytics at Scale, and we've sort of talked about how you build a dashboard that integrates with R and Python, but where's the at scale, right? We've had discovery, we've prototyped, and we built that foundation that is now a framework on which, it's a forecasting framework on which we can do a lot of testing in our entire organization. How are we going to scale that out to the entire organization? And we would argue that there's two types of scaling out. First of all, it's just the number of people that are going to be involved in building these dashboards. Hopefully, it drives a lot of adoption in the organization. More people want to be involved with this, so it's just more people getting into the process of building these dashboards. And of course, second of all, there's also just the sheer number of people accessing and consuming dashboards that call upon an external service. So how can you build, from a both technical and business perspective, build something that allows for this to still work and be fast and be easy to use and be powerful?
So let's begin on the technical side. For instance, when you have that many different business users trying to interact with these dashboards, you'd want that experience to be as fast, as performant in general as possible. Now, in order to ensure that that is essentially built into and architected from the very beginning, you of course want to take advantage of load balancing. Here, as one solution, you could use something like HA proxy. HA proxy essentially allows you to have several different R environments, as in this example, when you could just, for instance, say, whichever R environment is not busy running a particular calculation can then be delegated to the ones that has the least load. That way, you of course have the ability to scale out, configure at will how this is all going to then take place. And to give you a bit of a sense of how this can work in practice, let's see a functioning environment.
Don't drop your mic again.
I'll do my best. Here you can see that I have HA proxy running on one node. And you see here on the rserv backend 3 different R services that I have running here alongside this. What this is essentially going to allow me to do is to route then everything through this node so that I can then delegate to whichever node is not being used at that particular time. So here, within my Tableau desktop environment, I can just quickly test this by changing out where I'm connecting my R environment to essentially then run through this. And I can now test that connection and see that it routes that request to whichever one of the 3 environments is not busy at that time. That way, you can essentially build out the technical scaling out in a very flexible and iterative process there as well. The last component that we should cover is how you can make these environments performant also from the standpoint of the operations taking place within them. Here, we can have the possibility to, for instance, heat up those external environments. Have those packages already be installed and have those libraries already pre-called in the instances as they're booted up. That way, they're not called up in the calculations themselves, but are ready to be used when the calculations are sent from Tableau. That way, you can also define how rserv should start, which gives you a lot of control as to what type of environment it should be running in. You can also define here, for instance, how timeouts work, so that if you have one very expensive calculation being run, you can have that essentially time out so you don't bring down that instance for all other users who are trying to do similar things.
Now, the other part of scaling out is just the sheer number of people involved in building those dashboards. Now, with more people getting involved, you're getting preferences along with it. Some people just like R and other people just like Python. Sometimes it's determined by the type of package you want to run, and it's more powerful in one of the other platforms. So the question is, we can currently connect Tableau to a particular external service connections, but what if I want to use both? Now, one of our very big, like a big organization in Germany that we work together with, we've worked on a solution using Flask. And Flask can route requests to the particular environment you want this to run in. And that can run on the different ideas, potentially naming conventions or something like that. You'll just get the request and send it to Python or to R, depending on the request. So you no longer have your Tableau server directly connected to Python or R. You split that up. You use your one connection in Tableau server to connect to TabPy, which you usually use to connect your Tableau to Python, and put Flask in the middle of that. It'll be sent to the appropriate platform. It's being sent back, and the results are coming back in your Tableau server. So it is definitely possible. We've seen this in practice. We work with customers setting this up. So don't feel that you're only restricted to just using one environment in your deployment. Now, with more people being involved in all of this, governance, of course, becomes a big hot topic, especially with GDPR just arrived, of course. Good news, once again, is that you probably already have most of this set up. Tableau server is already set up to run all your securities, and you can leverage what you have, all your users and your groups and your projects, to make sure that, for instance, only your data scientists will have access to the underlying data in the dashboard, whereas your business users can only interact with it. That'll ensure that the validity of the model will not be tampered with by those that did not have training in it. Governance is, of course, a topic on its own, but it's always good to note these things down when you start to build out the solution, because it is going to be important down the line. Now, building a solution is never linear. It's usually something that needs to be iterative and continuous. And how do you make sure that is actually the case? Now, we already mentioned that center of excellence, and you should start fostering that in whole different types of ways, whether that's by executive power, just pumping resources into it, or just giving them a space to interact, whether that's on server using @ tags in a separate project, or just on meetings. But also bring that into the entire organization, right? Set up fun meetings, organize hackathons, not on something cool potentially, but also hackathon on how to translate those statistical terminology into understandable language to any business user. Those engagements generate a little bit of buzz in the organization, but the end result is always something that's better for everyone involved. You can set up doctor hours with people making up that center of excellence to make sure that questions never go unanswered and people have a place to go. There is, of course, once again, that particular session on the center of excellence, but it's crucial in making sure that it's not linear, it's continuously being evolved. There's a lot of activities that you can do. A lot of them you'll see here. I mean, Tableau Doctor, of course, is something that we run here as well. Now, before we wrap up and summarize what we talked about today, I'm sure that there's some questions out there, so I do believe that we have some time for those. So before we go into the summary, anyone has a question? There's a mic in the room. Don't be shy. We got one here. Yeah. We'll just, there you go.
Yeah,
I think so.
I think it is on.
I see that, yeah.
hello, testing.
Yeah.
Yeah, just a question. When you bring the R back, how would you bring back multiple variables back from R? Or can you only bring back one? So in your example there, you did a model when you brought back the prediction, right? Mm-hmm. How would you bring back multiple? So
So when you're bringing back calculations from R, you can essentially have as many calculations as calculated fields, right? Because the R calculation is just linked to that calculated field itself. So if you have 20 calculated fields that are calling upon R, you would then just see that would then call back to R and then get that sent back to your dashboard, if I've understood your question correctly.
So imagine you did that prediction, you fitted a model, and obviously the response, well, the model in R would have, loads of things, estimated variables, t-values, everything. So how could you bring that whole object back, I suppose? Not just a single data point.
So we have one example that I think I can run you through here. So, for instance, here I've called back on this tooltip the entire object summary that I have related to causal impact, right? And that's just another calculated field. So if I wanted to be very verbose with the type of results that I'm calling back, provided that they fit one of those 4 data types, I can essentially have a very long string value called back on that same dashboard. You, of course, wouldn't be importing back an entire visualization from like ggplot2, but as a Tableau employee, I suppose I have to ask ggplot2 versus Tableau. There are, of course, advantages with ggplot2 in certain instances, but Tableau is pretty flexible and pretty good. So you would have the possibility to essentially import as many calculations as you want.
Are you able to run tests? Say maybe you fit a model. Are you able to run tests straight and from Tableau? Or do you need to go back to R and run all the tests and then just deploy a model that has already been tested and stuff?
I would say here that depends on how you define this workflow between these teams. Some people will prefer to run these tests and have the entire model be pre-created within an external environment because that's what they're used to working in. And then it's in that moment when they want to present the end product and have a possibility to give interaction to, or give interactivity to your business users. That would be the point where you could then switch over. So I would say that it's very use case and workflow dependent as to what sort of load you place on either setting.
Hello. What are the limits that should be considered before building a dashboard integrating with R, Python, or MATLAB in terms of limits, in terms of data size, or complexity of the code, or number of calculations, parameters, etc.?
I would say as a broad indication, that of course depends on how performant those instances that you are connecting to are, right? But I think there are a few key components to cover off as well. Within Tableau, within this example, we are seeing everything here aggregated on the weekly level. I don't have to send all of the underlying data if I want that calculation to be performed on the weekly level, right? So if I aggregate my data when I've then sent that calculation, and Tableau will essentially just send the level of aggregation that you have on your view, because it's a table calculation, happens at that last step. Again, Constantine and Leonard's session, fantastic to cover this in more detail. But I would say those two considerations, I would say, drive whether or not the performance of your dashboard would be impacted in some way adversely.
And there's other, I mean, performance is usually the one that dictates it anyway. And there's also the question whether or not you can potentially pre-calculate certain values. If you're looking at Twitter sentiment analysis, the tweets can change, but maybe you can pre-calculate them anyway. You do that on the database side. Whereas if you're looking at clustering, the context becomes a lot more important, and you do all want those data points in there. So it's user-based specific. It's can you pre-calculate? Because if yes, why would you run it as part of an iterative? Because there can be just pre-calculated anyway. Sometimes it's volume. Currently, ABN AMRO Bank is doing a customer session. They run a Python script to detect anomalies in their transactions, in their trades, but it's 16 million a day. So you run that in your Hadoop Spark cluster, pre-calculate that, and bring that back in Tableau. Talk to Marlene, it's an amazing use case. She also uses the dashboard, the Tableau dashboard, to then have the business users report back whether the detected anomaly was actually an anomaly, and that's being reported back into the model to further train the model. So if you find Marlene Meyer, she has a great session on it. She's a real-life example of how you put this into practice. There's a couple of considerations, so not a straightforward answer, sorry. Oh, great.
Yeah, could you just touch on what's the significance or the consequences of these being table calculations within Tableau? Is that important to understand at all?
So table calculation means that it's run as the last part of the order sequence. So it's running off of the calculations in the screen. So one of the table calculations that people use in Tableau quite often is a running sum or something. And what Tableau would do is just plot the total sum of sales for each mark and then add on the previous value. So it first generates all the values within the view and then runs a calculation based on those aggregated values. That's what the table calculation part of it means. So you're running it on these aggregates. In our particular dashboard, that means weekly. So there's weekly results there. Yes?
Yeah, so when working with data scientists, two questions I get very often,
All right.
almost every time, is how do I get granular record level data into those calculations that should be run in R or Python? And the other one is it possible to have any access to the data frames that are within these environments? So is there anything coming up in Tableau around these aspects? And the second question would be, how do you approach these questions at the moment?
So let me just verify that I understood the first question correctly. That is the first part of your question, how do I give my data scientists access to the lowest level of granularity of my data set to allow them to work with it in that way?
That's what you're asking essentially.
Yeah. So I would say here, with Tableau, you can of course have that connection happen directly to your data source. And then, as we were talking about before, you can aggregate it. So here within that weekly example, but there's nothing stopping you from essentially giving your data scientists access to the lowest level of granularity in your data source as well. I would say that it depends here a little bit around what the data source is, but provided that Tableau can connect to it, there within our example, we created a data frame on the fly in that calculation, right?
So the calculations of table calculations,
Yeah?
that has limitations.
That does have limitations from that standpoint of you can't bring it up in that level of operations, and of course that you're not persisting that within that data source. But I would say that there it becomes this debate surrounding what are the advantages that I gain from having the flexibility of having things calculated on the fly as a table calculation versus what is the performance gain that I'm given when I persist that in the data source, as we saw with the Twitter sentiment analysis. I would say that there are, of course, times when the data frame structure that, given that we can only look at data output and not a data frame being imported, but you can, of course, make a table in your data source that resembles that data frame and perform the calculation on the column level and achieve the same effect, I would argue.
Cool. We are one more. We will stick around a little later as well, but just in the interest of time, we'll do one more and then we'll just stick around. Sorry. Yes.
I have a question. Maybe you already answered, but I'm not quite sure I understood that. So basically, let's say I would run a PCA on R, right? So I would like to have results about individuals and dimensions, right?
Can you speak up a little bit?
Sorry. Let's say I'm going to run like a PCA on R, right? So I would like results about my individuals and obviously my dimensions, right? But my dimensions are not in the dataset, right? So first, how could I do that? And second question is regarding the governance. What if like I have user filters in my data source and I want to run like any R script or Python, doesn't matter. Does it use the whole data set or the filtered data set? I think that's the filter based on what I heard. And can I kind of force him to use the whole data set?
So I'll just cover off the second part of the question, then jump to the first. So the second part of the question for everybody in the room, it was essentially around when I have user filters, what is it that Tableau is essentially sending to a model to be trained or to be calculated? And you're correct, it will be the filtered version, which thereby prompts a follow on, how do you get around that? I would say that there's definitely scope for having different parts already be calculated and you're calling just the coefficients of a pre-trained model within your R environment. So that's covering number two. To say number one, I would say here we're probably better taking that particular component offline. I'd say that there are different ways that you can come around how Tableau performs these calculations that essentially allow you to achieve the same end result and essentially get around some of these by just having your data source be structured in the way that allows you to get around it. But I'm happy to take it offline afterwards.
So in that interest, let's summarize what we talked about today. And then we can let you guys go out for data night out, right? We don't want to keep you in here too long for that. There you go.
So let's just recap. What we're essentially able to do is, of course, bring in that external service connection to perform more advanced types of calculations. And as a consequence of this, with combination of parameters and that context that our business users are aware of, be able to enrich that degree of collaboration so that we're able to communicate our results visually and get feedback from our users, for instance, using our commenting feature. I would say that, as Erwin was touching on before, many of these types of organizational pressures are similar to that we might have discussed with database administrators, right? And around who has access to this data with regards to that competency. I would just say, though, now, as a final point, because there might be some of you here within this room who think, why should I give my business users access to these things when they don't know what it is that this really means? Do they understand all the nuances of this fully? I would say don't let the perfect be the enemy of the good here. Think about the fact that it is a really positive step to bring these people into the discussion regarding the validity of the things that they're claiming. So you avoid that margarine main situation of just claiming that something is really linked when it's just spurious.
Furthermore, if you want to take away some key characteristics, we talked about making sure that the solution always adhered to those four that we see on screen. Make sure that it's easy to use, fast, powerful, and of course visual. Now when you start building that protocol, start using that framework all the way from discovery, prototype, foundation, and scaling, and then add that additional step to make sure that it's continuously developed within the organization. Get your champions involved. They will start your center of excellence and really make sure that this takes off in the organization. And just in general, create that iterative organization that promotes feedback and creates those amazing dashboards that hopefully will deliver a lot more value to you. So our conclusion is basically just get out there, get the hands dirty, find a cool use case, and get started. Hopefully you feel that way at the end of this session. Well, at least we hope so. Why not? If you want to learn more, we've already mentioned it. Advanced Analytics with R and Python will run tomorrow at 3:30. If you want to really start scripting yourself, it's a great session. There was a section on the Center of Excellence with Tableau. That's already passed, but it should be on YouTube come Monday. You also have access to the slides of that. And then that only leads us to ask if you could please review this session as well on the app. We work on this quite a bit. So we do take the reviews very seriously and want to improve on it at all times. So please let us know what you thought. We really genuinely read them. And with that, we just want to thank you for your attention. Thank you for tuning in. And have a great data night out for everyone in the room.